What's up guys, David from FX Layouts here. Today for Fuzz Friday we're going to be checking out this dirt transmitter from Earthquaker Devices. I think this one is being discontinued by EQD as it's not showing up on their website anymore and doesn't appear to be getting the top mounted jacks and soft switch treatment that a lot of their other pedals are getting. This could mean that down the road StuMac will be getting a kit for it, but with the kits they generally don't put out the schematic, which is what we're interested in. So today we're going to crack this open, figure out what makes it tick. So let's get started. Alright, so then we got this thing opened. We can move it around so we can see the back of the PCB. Board mounted pots, pretty standard. Alright, I don't know if you can read it in the video, but the transistors are 2N1711s, both of them. They look like germaniums, but the 1711 is actually a big old silicon transistor, just a fairly low HFE. I'm guessing that this is probably the filter cap, power filtering. It's probably 100 UF. It should be written on there somewhere. There it is, 100 UF. So what I'm going to do is look at, I'm going to grab a piece of paper and start drawing up a mock-up of the circuit board and figure out what the values of all these components are, and then we'll figure out the various traces. Okay, so that's a pretty good approximation of the circuit board. These tabs here, these are the transistors here. These tabs indicate the emitter, and I know that the pinout for the 2N1711 is pretty much the standard C, B, and E. Like so. These round things are the board mounted pots. This is the tone control. And it's nice on the PCB, it says B50K, so that's easy. B50K. This is the level or the volume pot. It is an A100, so log taper. Here's the fuzz, another A100. Okay. And finally up here in the middle we have the bias, which is a B5K. Alright, so now that we have the basic layout figured out, let's take a look at the component values. We know Q1 and Q2 are 2N1711, so we can write that down. 2N1711. And we know the pot values, but the easiest next step is to figure out the values of these electrolytic capacitors. I'm guessing this one is the power filter, as it's the biggest one on here, and it's 100 UF, which is pretty standard. So we're right here, 100 UF. This one is 22 UF. The next one is 4.7. this big guy here, somewhere on here, 47. 47 UF. And then finally this one is another 22 UF. Alright. Obvious one right here is this diode. Since it's over here by what I'm assuming is the power input, yeah, and it's coming straight off the DC jack. Battery snap plugs in, yeah, back there too. That has a big 4001 on it, so I'm assuming that is a 1N4001, which is also pretty standard for polarity protection for the power supply. So we're starting to get an idea. All right, next we have these little box caps here. Probably not going to be able to show up in the video, but it says 6 and 8, which would be, that's the value, so that's 6.8 nanofarads. The same. Are we gonna get that lucky? Try this open. Break them a little bit. See if that's the same. What it says. But yeah, 6 and 8. There, if you're curious, rated at 63 volts. Most of the caps are 25 volts, except the big one, the electrolytics. The big one's 35 volts. You could run this off of 18 volts probably. Yeah, these are all 25 volt. And that little one's actually rated at 50. Anyway, so these are both 6.8 nanofarads. And see these Panasonic film caps. This one says 101 on it, which is the capacitor code for 100p. Yeah, 100p. 100 picofarads. Cool. Then up here is another 101, another 100p. And this one says 471. That's a 470p. Okay, so some smaller value film caps here. Okay, so that means that these are probably going between base and collector. Both of these, just a guess, because that's normally, if it's that close to the transistor, it's probably there to help filter out, some of the high end that you can get, or some of that harshness that you can get with silicon transistors. So far, this is looking kind of fuzz face-ish. From the demos and playing this, it doesn't sound like a typical fuzz face. Which could have a lot to do with those transistors. All right, let's figure out these resistor codes. Let's start from up here and work our way around. This first one is a red, red, black, red, brown. And I'm not for a minute going to pretend to know resistor codes off the top of my head. So let's pull up this handy dandy resistor code calculator. So the first band we said was red. The second one was red. Third one was black. The multiplier was also red. And the tolerance is brown. Okay, so that's a 22 kilo ohm and 1% tolerance. So this next one, wedged between this film cap and the transistor, is brown, black, black, brown, brown. So again, back to our resistor calculator. Brown, black, black, brown, brown, right? 1K. This other one hiding under this transistor right here. That one is a brown, black, black, orange, brown. Head back over here. Repeat, you guys are getting the idea. This is kind of monotonous. Brown, black, black. Something tells me this is probably going to be 100. Orange times 100. Wait, that's red. Orange. 100. 100 kilo ohm. This one hanging out right here by the bias pot. That one appears to be orange, orange, black, brown, brown. Let's see what that one is. Orange, black, brown, brown. 3.3K. All right. Now for this guy over here. That's a brown, black, black, brown, brown, which we know is a 1K from, it's the same color code as this over here, which was a 1K. All right, so let's move down here. I have a feeling this might be the current limiting resistor, or CLR, that limits current to the LED from 9-volt supply. That one is brown, black, black, red, brown. Brown, black, black, red, brown, 10K. Yeah, I think that's EQD's standard current limiting resistor value there. But we'll see. Now for this one right here, that one is blue, gray, black, brown, brown. Blue, gray, black, brown, brown. Oh wait, red. Alright, so that's a 68K. This other one hiding on the other side of these big box caps is red, red, black, red, brown, which is the same as this one up here. That's 22K. So that leaves us with these two. And since they're kind of close to the input pad, or the iPad, which I'm guessing is input, and tracing it back to the switch. Yeah, that's probably the input leg. Yeah, that's input. Pretty standard foot switch wiring here. They just kind of skip the jumper here and just jumper it straight up to here. It works the same, just a different way to do it. So this is one of these is probably a pull down resistor. So let's take a look at this one. That one is brown, black, black, yellow, brown. Yeah, 1 meg. That's probably the pull down resistor. And then this last one here is yellow, purple, black, brown, brown. Let's see what this says. Yellow, purple, violet. Yeah, that's violet. We'll call it violet. Black, brown, brown. 4.7K. So here's our drawing of the circuit board with all the values filled in. It doesn't appear on the top of the circuit board that there are any traces along here. If they are, they're under components and they're really hard to see. But this is a fairly simple. It's looking like it's a pretty simple circuit, possibly fuzz face based, and I'm thinking most of the traces are going to be on the back side. So let's take a look. So this might be a little difficult to see because of the way the pots are oriented, but I'll try to bend them up carefully so you can kind of see, and hopefully we can figure this thing out. Here we go. So we have plenty of traces on the back. This one, I can't tell if there's like a ground plane, or maybe it's probably a ground plane. But here we have a line that goes all the way around. And goes into this first pad here. If you flip the circuit board over, this is the pad that says V1 or V plus. So that's probably our voltage rail there that loops all the way around. Cool. So that's starting to show what connects over here. That connects to that pad right there, which I think is, oh yeah, that's the what is that? That's the, okay, yeah, that is the this is that 10K resistor is the current limiting resistor. Okay, mystery solved. Let's see, the bias pot is probably a good place to start because biasing generally, especially if this is fuzz face based, is controlling the voltage going to Q2, which I would guess is over here. 1, 2, probably. So this 3.3K resistor does seem to connect to that voltage rail, and then connects to, yeah, I think it connects to like 1. So this is going to be kind of hard to at least film the tracing of this without desoldering all the pots, which I really don't want to mess with, in case I break something. You guys may have to take me at my word for this. So I'm going to go ahead and trace it off camera and show you the drawing that I come up with. And from there we can kind of start laying out a schematic in, probably do it in Eagle, because it's a good, I like that, the schematic generator in that. Okay, fingers crossed. Trust me, guys. Hopefully I know what I'm doing. Alright, so I've traced out everything. It is a single-sided board. and there is a ground plane. Anything that doesn't show like a connection, like the 6.8 end cap here or here, those are all ground connections. So it is kind of fuzz facey, though the first transistor stage is a little different. It has a resistor to ground in parallel with a this 22 UF cap. So that's different. That's not on a fuzz face. The tone is a modified Big Muff tone stack, I think. Comes off of the second stage here through this 22 UF cap. A 22K resistor to tone 3. No, tone 1. I should have labeled that 1. Tone 1 and a 6.8 N cap to ground off of there. Then that same signal goes over to this 6.8 N cap. Oops, I missed right here. That's connected. That then hits tone 3 with the 68K resistor going to ground. Off of tone 2, it goes straight to the level, the volume pot, to 3, 2 to out, 1 grounded. There's a feedback resistor here, like in a fuzz face, off of the base of Q1 that goes over to the emitter of Q2. Yeah, let's get going and draw a schematic for this in Eagle. Alright, so here I've got Eagle. This isn't going to turn into an Eagle tutorial. I'll probably do one eventually, but for now we're just going to draw the schematic and design a board. Alright, so there's our schematic. So yeah, it looks a lot like a fuzz face with a fixed fuzz control, but with a pre-gain here. But this makes it more like 2 gain stages punched into each other with the feedback resistor, and then Big Muff tone stack and kind of typical bias control for a fuzz face kind of circuit. No gain recovery after the Big Muff tone stack, but I mean this thing's plenty loud, so you know it doesn't always need it. The Big Muff probably doesn't even need the gain recovery stage. That's neither here nor there. So yeah, I've got the schematic created. Let's start working on a circuit board. Well guys, that wraps up the dirt transmitter. If you guys want to build one yourself, obviously you can etch your own board using the layout we just created. I'll probably tweak it a little bit between now and when this video goes live, so don't freak out if it's a little different. I'll also put the boards up on OshPark. The link will be in the description below. You can order a couple boards that way, or in a couple weeks hopefully I'll have my own boards in, and I'll put them up on Reverb or something, and you guys can order them that way. I'll Instagram, Facebook, whatever about it, and you could go that route if you so choose. Other than that, like, comment, subscribe, all that jazz, and thanks for watching.